Okay, maybe I'll just, well, listen to this while I announce the stream. Okay, so I'm just going to let's start. So what I was looking at before I started this is that there are a bunch of, actually mostly are enhancement requests, but some are issues. So we have one problem with the C3I files are marked extern weak by default, which is 5 weeks, but oh sorry, actually it's the problem is 3336. So compiler won't complain about redefinitions on C3I files. So honestly, I don't know if I want to fix those now. Okay, anyway, well, let's, I'm going to start somewhere at the bottom. I'm not going to, oh, hang on. It's this now one, not, there's a pull request, I think, for rectangle int. This is, let me just merge that one, so. That's why I thought this was already merged. Okay. So let's go ahead and pull that fix. Okay, so good. Well, we have some older issues that I was going to have a look at. So so let's see here. So there are well, I'm kind of looking at, there are some feature requests, right? So like features containing values that I'm kind of resistant, because the point of the features was that it was just a boolean and avoided the whole problem with, you know, having a value that has to be parsed and so on. But it could be like a string, of course. But anyway, I'm drinking some stuff ice here because it's a little warm, but it's not as warm as in probably most European countries right now. Okay, so I'm kind of looking through the bugs enhancement requests. So there's a add offset to bit struct types, and so I am just going to see if I can do that. So we have basically the feature request is something like this, right? But it should not be offset, it should be bit offset, right? Because you want to know like how many bits. So we are going to implement this, right? So okay, hang on, this it's yeah, it's supposed to be 6, right? Yeah. Hang on. Let's see the code here. So okay, right. So we are going to implement this. So why is this an error? Let's take it from the, okay, crash. So okay, let's get a main here, and put those in there. Not sure why this is a problem here, but okay. So this should not work now, right? Okay, of course it's let's put them in B, right? A. And this is kind of a low-hanging fruit. Okay, maybe I should just check that everyone is able to watch and stuff like that. Okay, I think I kind of lost the chat somewhere. This happened before, and I was able to get the chat back, and I remember custom browser docs. No, that was like a way to do it. Open multi-view. No, I don't want that. Okay, I'll maybe here somewhere. No. Okay, I'll just open Twitch and try to see what you're writing from there. So let's just make sure that there's no echo here. Okay, let me find myself. Make sure that I'm actually streaming. And can I silence myself? Yes, good. Right, okay, so now I can see you. I can see that there are some people in the chat. Good. Okay, so now let's hide that one. Okay, so what we're gonna do is trying to fix this. So we got missing semicolon first of all. So let's see what happens. Wait, this whole thing is weird. So, oh, that was fine. So it's gonna be like who be. What? Okay, no, it's gonna be reflect, right? So it's gonna be let's get the B here, like this. That's the way we're going to extend it. We'll see what this returns. Okay, it actually returns something. Okay, it returns 0. What happens if I have like bool C is at 10? Is that giving me like the right, or is just going to return 0 as well? So it's going to return 0. Okay, so it's kind of completely broken at this point because these should not be returning any offset at all. But okay, let's go through it. First of all, we need to add, we can jump to the, where we'd use these. So reflect something in the analyze reflection axis. So here's where we add these properties. And we have the keyword. So now we're going to add a new keyword, which is going to be like the bit. Const char keyword bit offset. Okay, so now we jump to where alignment is to kind of find the rest of the place where we need to define this. Okay, so we just use elsewhere. I don't need that, but we're going to need here. So keyword bit offset is going to be keyword def bit offset, right? And then we're going to add this extern here. Extern const char bit offset. Okay, so now everything is like kind of hooked up for that. Here, yeah, so everything is hooked up. So is alignment okay? So then that's one thing, right? It's type. And we get the offset. So we get to the reflection offset, and then see like is the const member? Yeah. But if it's a member of a bit set, then we should not grab that, right? So if You do like that. Reflect. Okay. I guess we can look at what the type is and how we retrieve that. Like the member offset is going to be kind of interesting, right? So anyway. So let's see. I probably should stop it here earlier, but so okay. Okay, so reflection offset, right? So reflect. This thing is a const, okay, and then it's gonna be have this member, const member, and const. We're gonna have a member here. There we go. And it has a declaration. I think it contains the parent somewhere. So I'm not sure, but I think we have a back. Maybe it knows it somewhere, so it feels like there should be a way to kind of see resolved attributes, method checked. The method, the field itself should know what the bit offset is anyway. So we're going to see, yeah, there's a lot of these different properties here. It's maybe unused, it's blah blah blah, it's dynamic, strip is da da da. And then we go into, because it's a member, it's going to be like a var here. And word declaration bit. Oh yeah, so it's a bit member, it can't have it. So so let's just say right. So if reflect member, let's get the member. Yes, reflect const per member, right? And if member, no, it's not. Oh, you get the offset in there. Stupid to me. Okay, so but anyway, so if reflect, hey. Anyway, okay. So that's reminding me of something. Okay, but anyway, if reflect const x per member decal var. Now really jumping into deeply into this var and the kind equals member. Return sigma error reflect maybe the expression. Cannot take the offset of a bit struct member. To use bit offset, perhaps. So something like this. Okay. Okay, did I do something wrong here? Let's stop it here. Okay, we are missing the context. Okay, so we have to add that one here. Okay, what broke now? Why do we have all these? Okay. Okay, so we have here, we got context. Right. Now this should say correctly, that doesn't have one. Right. Let me look at chat. So, hello. Which type of game are you developing, bro? No, there's not another game. It's a programming language called C3. There is no property offset available for the reflected expression. What? Oh, wait. Okay, so, okay. Okay, so we just return. We didn't need that. Okay, let's revert those changes. So just, it's not as great an error message, but it's probably, we don't need to make this change here now, at least. Right. We kind of have a uniform way of doing this. Okay, so right. Okay, so that failed, right? So that makes sense. So if there's a like it's okay, so now we can go into like is a member or not. What does that mean? Okay, if there is some thing or what? It's a const member, right? Okay, so if it's a member of some sort, we can get the tag of it, right? And we can get has tag and so on. Because the offset, that's like a general thing, I guess. Okay, so if the name now is keyword bit offset, then we're just going to do this maybe inline or something. So, well, it looks like everything is just doing like if not sim actually we could do like this. If member, so it's a member and the member is, that means the declaration, right? Okay, so if member kind the kind is not declare var. No, it's a okay, it's a member. No, okay, let's go the var or member var kind is not declare bit var declare bit member. Then we go to failed, right? Then it fails. Okay. If it doesn't fail, we want to return the offset. So expression. Oh, it's going to do the same thing as for the offset. So let's see what the offset does. Right. Where is that? So we have the. We just rewrite it like this. So with here we go. So something like this, right? Okay, we don't want that. We want just a bit offset, and the bit offset is going to be something. Now I don't remember if that bit offset is like stored inside of that member, which I do hope it does. It is stored there. So member var. Okay, so we are in var. And I think we have like this somewhere. Yeah, we have like the start bit, right? So start bit, right? So we don't know how long it is though, right? So the bit offset is a bit, oh, haha. It's a bit bad, you know. Maybe we should have both or something, but the question is what it should, contain then. I don't know, like maybe the bit offset is like a good start. You don't know, you can like look at the next member and see what the next start bit is. It should be like a bit range, but we don't have that concept of a range. Not here anyway. So let's just, for now, we're going to just return true here. And we're going to get the bit offset instead. And see if we can find that, and that it's cool. So any questions so far? Can we get the bit size? Yeah, we can get the next, but it's not perfect, the next member, that's not perfect. Because you could have like it, like in this case, look at this like this. Actually, the range is that, so we could have bit size. Yeah, we can have bit size. So let's add a bit size, right? Because that's a nice solution. That's a good nice solution. We call that bit size. So const kiwi bit size. Because these additions are so super cheap. Now they're super cheap now. They didn't used to be. Because before we kind of used up everything, like all the names. So bit size. Yeah. So we call okay, bit size. There we go. Size. And let's see, here we go, and we put it here as well. Like people tend to complain that you can, like in this case we are doing the same thing and it's not very compact and stuff like that, but it's very easy to read and add to. I think that oh, I just remember something about min and max that we're going to look at after this. Okay, so we're gonna add we're gonna add this other thing. So we're gonna have the same thing, bit size instead. So let's take the bit size. We could just check that if it's not, well, no. Okay, so bit size, and then we're gonna have like the bit minus the member var. I can have to get the var start bit. This is a bit wasteful, right? Maybe we should use the pointer. Okay, so something like this, we should be able to get like both that, and so we can do like then. So the range is like this to this. So it's like A, and then we're gonna have this size and -1, right? Okay. We could do like this. So for each, then we have a member, right? Member in two members. Then we can do like a ban, print that ban name, and it has a range of this. Then we need the member name, member bit offset, member bit offset plus member bit size -1. That looks okay, or? So let's run that. Maybe I did something wrong and it doesn't work, but kind of looks right. Zero to 1, 6 to 6, 10 to 10. Yeah, works. So I guess the test for this bitstruct. Let's see where we got that. Okay, bitstruct reflect bit size C3T. Okay, and we need okay, we'll do this target. And so you're gonna have like yeah, maybe just do like this because it can be like a good code jump for this, so we can get like a and then if B. So when we create the code for this, or when we generate expect, so generating code for this will be fairly clean and easy to test. So we're just gonna run the tests now. Meanwhile, I'm gonna add, oops, that was not good. Release notes, we're gonna add this. So add bit offset, oops, come on. Add bit offset and bit size to struct members. And now we're always looking at the offset inside. There's a limitation here I didn't bother with, but if you have like a bit set, you have a bit struct, right? And it's an anonymous bit struct. Then you're gonna get like a bit of a problem. So we maybe we'll look at that next. So meanwhile, I'm going to look through the through the podcast. Okay, this is I should just write this down so it's also in 3, 2, 1. So that's the thing. All right, so I'm looking back here at features that are missing or accepted or anything like that. I really would like the decentralized package discovery fetching to work. If someone wanted to do that with me, I'd be happy. Disallow concatenating streams, but no, that's another thing, right? So feature request, next case and break-ins, compile time switch. That's one that we don't like. Yes, it's good, but it's not super necessary. Enum lookup value for, okay, implementing, okay, that's other things. That's for build target dependencies, right? So Um, no, it's a pain to do quickly. I can't do that quickly. Okay, let's look. Vendor fetch. Okay, we talk about that, whether we should be unzipping or something. I mean, like this unzip by default, you can certainly have that. Fetch. It's just that I didn't like the people submitted some things to the compiler doing that, but the implementation was not so good of that. It didn't kind of match build set the way build options were handled. Speaking of build options, that's another thing, by the way. I should have a look at limiting the length. Right now, it's just multiple rows is fine. Just push it, just prints everything. But it should, look at the screen length and then do a row break. Okay. Allow direct usage of generic type parameters. Allow an alternate, like there's one of these. Yeah, I'm just going to allow that one. Probably I'm just going to like so there's another one. Well, is it done, by the way? No, it failed. Oh yeah, of course it failed. It should fail because this is the way we kind of add this. It's just, wait, did I? Okay, what? Okay. What the heck? So this coding is crazy. Coding is completely crazy. Both are these, right? Let's just add a function dummy. It takes like a size and doesn't do anything with it. That's like, right. So we can call dummy. What the heck happened there? The coding's like doesn't make sense at all. Okay, did I do something and then okay, just let me run this again. Maybe someone saw what happened. Min and max. Doom was that. Oh yeah, I mean there's this I know. Right now it's just looking at this one. Let me see if I can paste it somewhere. I'm looking at this one, and I think this that one should be rejected. This one, alternate. Okay, so I'm just gonna reject this one. Rejected. Not that. Cause okay. Okay, so let's go. We have. Okay, we're gonna get that. Okay, member. Yeah, you're seeing that. I'm looking elsewhere, you know. But okay. Well, at least it crashed early, right? So, any questions by the way? So there are more of these properties. So so those should be added, but we have the generics, right? So we have, when we want to be able to get the generics parameters, and the tricky part, like people want, oh, I want to, you know, grab it by name and grab it by index, but I just want that by index, really, because otherwise there has to be more machinery around it to kind of grab that. So let me, oh, well, okay, we are back here. So what? What? Okay, let's just run this code and try to see why it prints something completely unexpected. So we just going to have like IO print then. Something is off. Something is very off. So it looks like it's doing something completely different. Yeah, so this is completely normal and makes sense. The output of this one makes no sense whatsoever. Okay. I have no idea. Like literally, it doesn't make any sense at all now. Like it's clearly not code generating that, so we make the okay. Yeah, okay. Well, I'll see what happens. Okay, questions while we're waiting for this. No questions? So, oh, by the way, I just didn't check if people see the entire screen. Right, you don't see the entire one screen. Just going to make it a little smaller. Right, so let's grab that. See if it's better now. A little better, I guess. There we go. There we go. Okay. I hope you see the entire screen. Yeah. A little better now, I think. All right, so what is this here? Okay, here we go. And I mean, I get the same thing. Oh. Yeah. Sorry about that. Very sorry about that. Okay. So there was like the tests are looking at files, but they didn't clean out the files. So it like, oh, there's a test, but I guess it was the old test doing other things, and then compared it, so that didn't make sense at all. Yeah. And I think we could be okay. So the release note should be like this, right? To that, and then we have to. Yeah, we should try one more thing before that, though. So let me see. Yeah, a little fragile. So when can we get the error? So come on, it's very slow now. There we go. Okay. So we stop it here, and we should get like, okay, the dummy values, which makes sense now. Okay, good. So we can just keep this. We don't need other stuff. So what happens though if we make this? And I think we can probably make it work. Okay. So instead of that, we have like a bar, right? And that one in turn contains a bit struct. So we have a bit struct, which is a uint, right? So do it like this. I think we can do it like this. I don't know, people really do this, so maybe there are other bugs with this. So let's do it like such, right? So now we get the same thing, just we don't happen to have like the bar instead, right? So the members here would be like we don't have the bit offset, of course. Yeah. Yeah. We're gonna have a member, but for that particular member, we're gonna get the so this is just gonna say there's no property. Okay, so instead we're gonna go for what we're gonna go for so reflect bar. We're gonna get bar what bar okay, members, right? And number 0 and get those members. So now we have the members in there. So this is the way you can get it. I think, right? Should be right. So now we get those again, but if I insert, an int x here, I want to get like, if I can do like I. If I is greater than 0, then we'll do this. And if, and then I plus plus right? So we go through the, okay, go through the members of, no, it's okay, it's gonna be fine. Right, so there's no need for this. So now the offsets are going to be like the same here. Like, okay, they are, no? Oh, so now, okay, because that one doesn't have members. Okay, so we get to 1 here. And they are giving us these values again. But what we could do is, like, when we look at these bit offset here, so do they already have like, if the parent itself has some offset? So we're gonna look at the member here. The member itself has a parent, of course. Okay, var, here we go. So we have these start bits, but do we have maybe an index as well for, we did this and have maybe like the original expression, which is the reflect here, somewhere there we go, reflect. And the reflect has a const, and the const has an offset. Const expression. Right, member. Oh, and the offset is this. There is something about the offset. What was that? So there is something special about the offset. There we go. So if it's not this, why is the alignment 5? Okay, I gotta go through this bit. So we are giving us, we have the members. Sigma expert. Oops. Let's see if we can make it work. Member access. Okay, no, I want the members. So let's see here. Symbols, members, something. Okay, that was not in there. Okay, so we have members of, right? And then we get a member, reflect member. Oh, here we go. So what's that? No offset. Line size is UN. So okay, let's go in here. Right, so we are doing this. We're getting the members from what type? From bar, right? Okay, so and we are, why do I have no offset? It's false. So the first one, expression element. Is a const member with the offset, hopefully 0, yeah. Then we're going to add that, and then we're going to do the second time. And what kind of offset do we get here? We're going to go to this members of again. So we're going to continue here. So now we're going to get this type, which is this bitstruct type. And what now? So we have the offset. We have an offset now. So, wait, we have. Why is the offset like that? So something goes wrong with the offset somehow. 1, and then we go 2, create that thing, and then we're going to go into an indexing of, we're going to subscript, we're going to end up resolving that, so we get this thing. So now the expression here is at this const. Let's see what the offset is. So const reflection. We have reflection, and that one is probably a member, right? So we have it's a little gnarly to look through these. So here we have the member, and the member, where are you? There you go, has an offset of 4 and alignment of 4, which makes sense. So everything is fine so far, right? And then we go, okay, go upwards. So we're going to go into the for each somewhere. Wait, hang on. Are we in here now with the everything that's broken? Yeah, we're in this with the offset. Goddamn. Okay, let me try again. So we're creating the members of. We're deep in there, so we're going to go up. And we're in the subscript. We're going up from there, up from there, up from there. We analyze the parent, right? So in our example, we had something like this. So we now have this. So then we go down here, down here, down here, and try to resolve the child. And with, like, if it's an reflect, okay, it's la la la. We're gonna go in here, and then we're gonna here, and analyze reflection access, right? And now we're going to go in here, blah, 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 and go, there is a const member. Okay, we got the member, right? Everything is fine so far. And then we're going to look at storage and a few things. And then we'll go to type, blah, 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 and we're going to go to the member. We have the member. We're going to go through here. And then final things we're going to look at is here. We go members. So now this parent here, should have an offset. So the parent is what? Is a const, right? So it's a const. But did something change? No, it's a const reflection. Oh, wait. So parent. Look, member here. But then when we're going to do this, members of, it grabs not this one. It grabs, yes, the parent, but member is, so we're going to go to reflect, and it should be reflect, right? So so it should be reflect. This is the correct thing. So we found a bug there. So now if we go into this part with the offset, things are actually going to look good. So it's not going to be like this weird stuff anymore. Actually, it's just going to go 1, 2, and now we're inside of there again. What's this going to be like? So we are in here with this thing that is the members. It's going to get a valid, actually, the valid offset at this point. So the decal, does it have an offset? So the decal's offset. That's just going to be bad, right? So what's the decal's offset now? So, let's see here. We don't want to add that for those. So we want this offset to be the same as we passed in. Const. Let's go to the member here. So the offset. Oh yeah, it's fine. So it's fine. And then, right. So now it works actually. So we can kind of get the bit offset. Now we're going to change that. So it's going to be like the start bit plus this reflect const expert. So align size base align. Align is going to be like a reflect const expert member line. No, offset, sorry. Offset, right? So it can be like the base offset. So if the base offset equals align size and then negate, so negation of this. In that case, we're going to set the base offset to 0. And so this offset is going to be base offset times 8 plus this start bit. So like this. Okay, let's see if this works. Right. Okay. So I'm just going to look at whether you wrote something or not. Oh wait, we got ours. Oh, okay. So we got 32, right? So that's correct actually. 32, 38, and 41, 42. Yeah, good. So we have the offset. But I don't know. Should we have that, right? Should be like, okay, what happens if we have structs, right? So if we have a struct, does it say where it is in the struct or not? Let's create another one. So we have struct baz, right? And we have an int x, and we have a struct, and we have inside of that one you have y, right? So which means what is the offset if we take baz and we take the members of that one and take the first member and take the members of that one, take the first one and ask about the offset. So is that one 0 or not? That's my question. The offset is 4. And if I have something like 100 here, so the offset is always, considered from the top. So that's correct then. Good. Goody. So now I have a new one, right? So we have a new test. Which is going to look like this and something. And we're going to go reflect the size here. So new. At one point I thought like maybe this is too annoying to add, but we actually fixed a bug as well. So now kids can want to go inside and like discover, oh no, daddy's streaming. Can't go in there. Poor kids. No, okay, anyway. Let's put this there and then let's generate this check. So these are regression tests basically at this point. We already tested them, create the regression tests so we don't break them later when we do stuff. Okay, Glass in streaming again. Do you always upload your streams to YouTube? I sometimes. The last one I did. Probably this one as well. Sometimes I just feel like that. I don't edit them or anything. I would just put them there, and then you can look at them if if someone is interested. It just takes too much time to really. I mean, I'm not a content creator. This is more like if someone wants to have a look at this, then just follow along and see what happens, or discuss stuff about the C3. They are welcome to join the stream. I really like this to I really like to do Q&A live. So if you have questions, please ask them in chat. I'd love to kind of elaborate on that. So anyway, we know this works, right? So no, by this. Oh no, sorry. Well, we don't know that at all because we're so we have the bass thing, and we didn't hit the error yet. This problem yet. Okay, so here we go. Oh, thing. Let's. Okay, sorry about that. I managed to pop the wrong view. Let's do it again. If you find the time, can you explain why no tagged units and pattern matching in C3? Right, yeah, so while we're looking at this, so we don't have like the full pattern matching, but you can, with the switch, you get like part of what people use pattern matching for. That is like basically super powered if else, right? So you can do that. But there's the binding part, and it just seemed too much to add that to C3. In other languages, there are things that kind of require it. So you would do a lot of this. Maybe you have a tuple or you have something and you want to match things. And you have also when you're expression based, and that also kind of ties into this. So you get a lot of mileage out of having this like full pattern matching. But in C, personally, I don't have the need for it that much. And in C3, I never also like. There's one place is the case of any when you do matching for that, and I had this any match. Actually, I did a special thing for that, but in the end, it wasn't really used, so I dropped it from the language. But anyway, so you don't get that much mileage out of that for C. And the switch already covers most of them. Variants with payloads could be used for parsers. Yeah, but it turns out it's not that useful. Like, it's not that it's a bad idea. Like, pretty much all the features that you can ever have in programming language, they're always nice. But you just have to, like, there's a budget for an amount of features, because in the end, you kind of pay for all the features. The users learning the language will pay for every feature you add. And so you don't want too many features because they are paying for it. It's not you. I mean, you can add as many features as you want, but they will pay for it. So that's why, people, at least I dislike, like, I don't want to jump into D because I know it's such a big language. Because I want to master a language and really know everything about it. And so, otherwise you get like kind of uncertain. Maybe I'm doing it wrong and so on. So the smaller the language, the more sure you can be that this is actually the right pattern. And also getting back to a language is also actually an appreciated problem. So actually, I because I'm old, I end up going back to language that I already learned. So and then I realized that I forgot about a lot of things, and the amount of things that you need to learn then that's that depends on how big the language is. So again, relearning C is not a problem. Relearning C++, well, that's a chapter for itself. But I just go back to Ruby and I forgot, like, how did they express if statements correctly? Like, because there is a difference how you do it, and I often end up using unless because I remember that one. If I'm like, I don't remember. I mean, because you start a block in different ways, and like the single line is one way, like they have the single line thing. Anyway, so there's an actual cost, and the more stuff you add, the more you have to recall when you use it. So that's why you kind of have a budget in terms of features. Like, some features are almost free. Like, you can add however many you want them, and those are kind of like, well, here's an attribute to make it work on this platform for this special thing, because no one will need to learn that anyway. Like, unless they really need to, okay, I want a naked function. Like, I never used a naked function in C. I didn't ever use that attribute myself, basically. I didn't do any OS stuff in C. So the naked attribute, which is in GCC, and is also, there's one in C3. Those are like free. You can add as many as you want because people won't be bothered that you don't know it, because they don't need to know it unless they need to do something that actually has that special requirement, and then you can look it up. So those are free, but something like match, that's like a big feature, and there are other things like that. So the thing I learned in not game design, language design, is that you have a feature. It doesn't matter if you have it or not. Like, it's not that important whether the feature is like the best feature. So like that a lot of people like you should, whether you should add it or not is not as important as getting mileage out of it. So the worst thing is like when you have a feature, but there are other features that people won't use that feature. So you kind of get the complexity of having that. You get the uncertainty for people learning the language of having that feature, but it's not necessary. So that's that kind of feature, even if it's simple to implement, it is that should really be removed. So that's a super big cost for the users to kind of lug around the entire language. That's how it ends up being, and you want to make that burden as small as possible, basically. It looks like everything is passing except the one that I updated, so we can kind of do that. Recently, people were discussing language design and stuff like that on the Odin Discord, and I mentioned like I was really bad at language design, as in like I wasn't even able to, I didn't know how to approach it. So that's an interesting thing, because another thing that I have problems with very early on when I started to like work on other things, like one thing that I like no one would teach you when you wrote networking code was basically how do you write a protocol. Like how do you write a protocol? Yeah, you can have all the networking we want, but what are you going to think about when you're writing a protocol for a game, for example? So I wrote actually a set of tutorials, but the way I learned it was actually I started working at on game back in 2000, like early 2000, 2004 or something, 2003. Anyway, so I started working there, and they already had this game, so they already had a protocol, so that kind of started from there, right? So then people would end up experimenting with other ways of doing, like how they want to package their messages and stuff like that. So you could do it in a lot of different ways, but I kind of found ways together by different people experimenting, like what's the simplest way of doing it. But once you know that, once you kind of have like starting from that one template, things get easy. Right? So then you can just write your stuff because you don't get stuck in like thinking about those decisions. And I think like for language design, also like the problem is like how do you want to start? How do you start organizing your language? So I think a very good idea is basically start with another language. So you start from one language and then you think about how you want to tweak it, right? So you basically write down that the way I did C3 was basically I wrote down C2, which is basically C, right? But tweaks the syntax. And then I tweaked C2, like added stuff, removed stuff, changed some of the syntax. And if you do that, you you have like the core is going to be like full-fledged. You don't have anything like special. It's like you start with something, and then you tweak it. And as you tweak it, you're gonna learn why the features that were in the previous language were there. And then you can decide where those things made sense or not. Or if you want to change that. Okay, but we're done with this one. So I'm just gonna push this. So now some people will be happy. I didn't think this was necessary. That's why it wasn't in there before. So now let's see where I put that one. So 3 something. Where was that one? 3 2. Oh, 3 2. 3219. There we go. So assign myself. Fixed. It's testing. Okay. And we're gonna set up milestone for it as well. Didn't have a milestone. Feature and it's accepted. Fix needs testing. Okay, good, goody. JSON Marshall creates invalid JSON for Unicode string. Okay, that's bad. Maybe like I think that, or I hope that people will look at the standard library stuff and feel like, okay, we can fix these bugs. So as a way to kind of get into the language itself or contributing. Allow multiple consecutive doc comments. Okay, that was not an approved thing. Let's see what's approved here. Accepted. That's what I call it. Label accepted. Accepted. Okay, so we have additional properties for reflected values. Is anonymous. So there's a request for is anonymous. Right, and that one is actually really nice because it's like this, right? So we're gonna go for this. So here we go. So let's have this struct from this example. We have the inner struct, and in this case, it's not anonymous, right? Wait. If the type is an anonymous union or struct type defined in a struct. Okay, they want that. So there are two things. So there is just for the type, and the other one is for the member, right? So we're gonna have both of them. So we're gonna have like, right? We're gonna have this. Oh, okay, we have something about what's that? So we're gonna do this. And we have like inner struct. It's anonymous, right? We're gonna go that one, and we're gonna go the other one, which is this. Right. So it's anonymous is not right. Anonymous struct is just one without a name, right? What's the right? So let me get the name, the actual naming. So I thought the anonymous was the one that has no tag, right? Yeah. I think like nested struct. It's nested and it's anonymous. So this one should never say it's anonymous. So there should be like we have now struct and we have like int y. So here we go. So actually this one is the type here is it's nested. It's nested. And then we have like the other one. So we have okay. So we have val, not val. We have type of, how do we, okay, we can get the member, right? So we can get members. Oh, my struct members one is anonymous, and this is just it's empty, right? And then Oh, it's anonymous, right? So that was one. This is it, but we're gonna get the type too. So we have the other one is like we have the type, and it is anonymous, right? So something like this, I think. So we're gonna need these properties first. We have this ordered here, so let's go for that. So is ordered const char keyword is ordered no, is anonymous, and const char is nested, right? Okay, and then we'll go up here, find these. Let's see here. So we have here QA is anonymous. Right, and then it's nested. Right. So we don't handle this yet. We need to do that. So first of all, if it is a let's see here. If it is cons, keyword is cons. So we're gonna go if it's somewhere in here. There's going to be like the type ID. So type and like cons reflection access. So if it's a member, right? So it's a member, and then we're gonna go if name equals QE is anonymous, right? And then it's anonymous if expert sima expert is we're gonna rewrite this into a boolean, right? So where is the boolean? Just gonna copy paste here because everything is very sluggish. So just thinking it's just rather than typing it. Okay, where were we? We have it somewhere. There we go. So we're gonna go for now. There are sounds. My wife is okay. Anyway, so we have member. If it's it is so we're gonna go for the type, right? So it's anonymous. It's first of all, the member has no name. Equals no, or just no. It's member equals 0 or I think it's empty, right? But I'm not sure, so I'm just going to go for this. This is actually going to be enough. It's just going to work for anonymous. Now we have nested. So if it's a member, right? So it's nested if it's a struct or a bit struct or something like that. So so if we have something like type is struct union or struct is that one. No, I want the other one as well. Bool of Instruct. Jekyll has members. That's the one. Okay, maybe not. Has members. Well, yeah, the member has members. So something like this. Is that correct? Let's see. This will work for the members, right? Not for the times. We'll fix that later. I'm back. What happened so far? Well, we created the feature. We had added bit offset, and we added, and now we're adding is anonymous and is nested. That's what happened. That's what's happening. Right. So okay. No, we finally complete. Oh, what? Like my computer is super slow now. By the way, I think it's like OBS is kind of eating all the energy. Okay, yeah. So there's none of these on the is in restrict key. That makes sense. That's the one I talked about. So yeah. So these are the ones that are not supported yet, but that ones should be. So we get an echo here from this, not a printout. So we get true and true, right? And we can get both, right? So we can get like is nested, is it anonymous? And then is it nested and is it anonymous, right? And for the first one, we get like it's nested, but it's not anonymous. The second one, it's nested and anonymous, right? So that's what we wanted. And we're gonna get like let's put these in booleans. So we're gonna have like this. Then we can make it a test later. And yeah, bool C and bool D. Now I need to go and grab some tea. So, and I'm just gonna write down. So, grabbing tea. Maybe getting some tea. So and right now it's like 20. It's 20 to let's say 10 minutes. So, okay. So meanwhile, I'll just put on some SID play for you to kind of so you can hear when I'm back, right? Or something. Maybe you will turn off the music. That was not good. But anyway, here's some nice Rob Hubbard. Okay, after this little interlude, I guessed the time almost right. Should like 3 minutes early, but right. So we're gonna get these working at you. So it's nested, and we're gonna get the so in order to do that, we need to add those as type properties. So type property, right? So there are type properties, and now these are the ones, right? We can add more. So we have, right? So type property is anonymous, right? And we have type property is nested. Okay, but then we realize, okay, we have this is ordered and it's defined in this way here. So we need to add those as well. Otherwise things will break. So we have is nested, and we have is anonymous. Yes. Nested even is okay. So we're gonna reorder the whole here. Okay, so now we have them, right? But we are not using them right now. So okay, here we go. Is this supported by it? It isn't. So case type property is anonymous. In case type property is nested. These are not runtime properties. We could make them, you know, could be true, but not, it's not. So okay, it's ordered, nested, and so on. Right. Now we already know the type. Oh, we don't need to. So we say it's like for these, right? So almost, right? Property is anonymous. Case type property is nested, and those are valid like for not all of those, but almost. So they're valid for these. Okay. So great. So now we can say that these are valid, right? So then we just need to implement them. So rewrite to is ordered, right? So we have case type property is anonymous, right? And now we have the type. We know the type. We know also that everything is valid. In the case of an anonymous type, we can just check for the declaration. Let's see what the declaration name is. So we do simma rewrite bool no expr expr rewrite constable. So we have this, and we're going to check whether this flat thing, or yes, if the name is null, or it matches this empty string. So flat name. And in that case, it's anonymous. Right? The last one is it nested though? Right. So how do we know that something is nested? For now, let's say it's never nested. So now we get a little upset that my daughter is in here and she is turning on the TV but having a lot of volume. Anyway, let's see that it works for the anonymous part at least. So we have the anonymous, right? So we're gonna echo, is it type anonymous? And what about the other one? If we get like type of, like this, is it anonymous? So and we get that both are anonymous. Oops. Now we need to look at this. So look at the how it's implemented, right? So I was thinking that the flat name was going to be like empty, but it's not. So the type here, in the first case, of course, it's false. But the second case has this one, right? It has a name now. And that was stupid because I was thinking like, okay, yeah, but the type name is different from the declaration. So the declaration might be empty, but the type will have this constructed name, like with a dollar sign. So now look at this. One is true and the other one is false. Okay, how do we tell that something is nested? I don't think I stored that property, but as you see it in the name, you can kind of get it from the name though. I don't know if that's a great idea though. So these are done. They work, so we can call them bool e and bool f. What we need, final need here though, is nested, right? So here both of them should return true. For being nested. And let's see what they I don't remember anymore, right? So I just do it like this. It's possible that it's already marked, right? But otherwise it also could not be. So while we know it from the name, maybe there's a better way. So as a variable, does it say that it's nested? Method checked. There's the struct thing here somewhere. Module exec, here go. Enums struct. Here it's a parent. So when a flat, I'll say struct, and then parent. If it has a parent, then we're fine. Right? So the parent is not 0, then it is nested, right? I can actually compare as well with the my struct itself. Right, so we have these examples. Okay, so let's remove that. And what do we get? We get false, true, false. So this one is false, this one is true, and this one is false, exactly as we wanted it. Okay. Then let's assign bools, bool G, bool H, bool F. What? Right, okay, right. So like this. So we wanted to like reflect some reflect. So something like reflect nested anonymous. Expect test. Oh. We need to have some. Oh, that was bad. So typically you also always set the target out, otherwise it will like add it for the target that you have. And in this case, okay, this case it's okay. It just needs to actually work. But here, since we want to look at the result, so here we go. Test all. And when we do that, let's write that down. So release notes. Is that add is anonymous. Add is anonymous and is nested to type to struct union bits struct types and to, and that would be 3 2 2 3. So I like this one. These are kind of like on the backlog. As you see, it's very easy to implement these now. Like before, it was easy, but the thing was that you had to worry about, using up names that you really shouldn't be using. Okay, any questions so far? All right, so let's see here. So what? Decode for Windows. Oh, okay, man. Music will sound wrong because of noise cancellation. Ow, sorry about that. Okay, there's some reason to see it about that. Sorry about that. Okay, I didn't see that. Okay. Anyway, okay. Okay, now I know. Now I remember. I'll remember that. I fiddle with OBS as little as possible, I guess. But we can have done now, right? So, there are more properties. People want generics, generic reflection, and stuff like that. These are not hard, but they're not also not like super priority, I guess. We have the 829 thing, which might happen or not, but probably not for the next version. What else? Kind of looking back here, there are things. Oh yeah. Okay, well, we're looking at this, or we're not looking at this. We're gonna look at the max. Right, so we have built-in max built-in somewhere, built-in. So we have a built-in max. Then we have a built-in that does that uses max. Where is it? Max. Don't we have a max? I thought it was built-in here. Min. Where's that? Because you get one like automatically, and then the other one is so let's see here, we'll get like a min, something like this. Where's the macro? Okay, we have the macro in comparison, right? So we have this, and it just it's actually not that great. It's kind of as you see, it just it compares a lot of them, right? And then in math, maybe probably not do this because it's getting late, but there is a max here as well. Right? So there's a max function. Where is it? And the thing with this one is this uses this built-in. So it still offers other things, but if it's numerical, then we can use this, right? So we kind of have this. You can like they are very similar, but this one is for numerical things only because it's more optimized, and this one isn't. But then like I get a little annoyed because this is a built-in, and then I have like math min, and then you have min. So something I was thinking about was maybe this one, this one should have look at, is it numerical and does it satisfy certain properties? If so, then we're gonna go for the optimized one in math. Let's see here. Okay, we have something like this, right? So we're kind of done with that feature now. I'm just gonna push it. So maybe those should be merged. So then this min and max, they will be eventually kind of deprecated. But you can see like, so if the types are numerical, right, this, right, so then we can just do floating point value. That doesn't make sense. Okay, so if it's like that, then we do the macro. So let's see here if there's if it's necessary that no, I don't need math. Right. So anyway, I was thinking about that. Thinking of like maybe adding that. So maybe we should have a look at that. So it's like this. So it's kind of easy. We start with max, right? So we have max here, and so what we're going to do is kind of here we go. And if you look at this, it's like it's a little stupid. I think I like it works. It works if it's even if it's like you know. Okay, so like if like we have these criteria for using that. So in this case, they kind of get more optimized. So if you know, times numerical. Okay, so wait. Okay, if args, okay, damn it. Args. Oh wait, I did. Okay, I broke. Well, let's doing this again. So arg len equals 1, and this, and type match. Type match arg0, right? If it's like this, then we can always do it, right? So then we can do like greater or equals to 1. Then we are in here. So we have the case, and we can just do this. So basically like this, we have the health here. Like this. What do you think? So you go into, like these are like thing is that these should like yeah. Oh, min. I added this to max. Okay, so we can just do min here instead. But you get the point. So then you can kind of deprecate the whole the other min max. So you can get, here's the optimized one where you have numerical stuff. It's numerical, by the way, which you want to side. So we have unsigned signed float vector. So basically those are true. But actually this is pretty poor. There are reasons why you shouldn't do this now, because we can have it's a bit like you could have a different comparison operator for the for the numerical for you have ID, for example, and you have a different comparison operator than you thought, and then you can't do the min like that. I don't know. Okay, anyway, so I think that's like pretty much it for today. I should see if you have any questions so far. There we go. So, okay. So that's about it. I don't know. Anyone having any questions regarding this or something else? Otherwise, we just say good night, and tomorrow's Monday, back to work, and so very little C3 coding, I think. But there are things that should be evaluated, so things to think about. That are not programming. So thank you, and see you next time.